Good morning. In this video, I will explain how to do the assembly for the U-joint. So let's do a new assembly. And my advice is the first thing is to save it. So File and Save as, the name of your assembly. And also you can check your unit. Okay, before I answer the first part, let's check my unit. It should be IPS. There is different way to go in the units, but if you go to all the options, I need to insert my part first. So let's insert my part first. Begin assembly. Let's brew the first part in the U-joint. That will be the bracket. And there's two options to snap it in the center. Either you have select this to see the origin, and with your mouse, when you go close to the origin of the assembly, here we go, it will snap it, and you click enter, or you click on the green arrow there. So we have our brackets. You can save. First part, that was the female on the top, or the male. Let me insert both of them. I will insert both of them and I will check which one. Oh, so you see the male, he has the pin, so the pin is going inside the bracket in the top. So let's put the mate between the male yoke and the bracket on the top. So we have a coincidence between the plane, so this one, and the plane below the bracket, this one, and enter. And we have a concentric, oops, not this one. Okay, let's remove. You see, I select the edge. I really prefer to select, oops. Okay, let's remove this one and let's do it again. I really prefer to select the cylinder, all the face, not just the edge. Okay. I think that could make things more stable. And always check that you have your degree of freedom that you want. So you want to be able to rotate the yoke mill, so you're good. This one, we need the spider and the pins before we can put the mate. So now let's insert the long pin. Why I click on mate? I want to insert the long pin. Here we go. Okay, so for this long pin, the long pin, I don't remember if it's going, which one is going. So let me open the document. So that's your Week 5 homework. I just want to check. So let's go on these documents. So you see pin long, that's the number 5, item number 5. So the long pin is going through the number 4, that is a female. So let's put the long pin. This one is going with this one. So we have a mate of concentric between this and this. Okay. Now, to center the long pin with the yoke male, my advice is to show the plane. So you select, oops, I need to get out the mate first, sorry. So I want to see, oops, the plane. Okay, so I want to select, why I can't show the plane? You know, who knows? I don't know why. Doesn't let me do that. Please, I need to select something different. Anyway, you can select your plane. Okay, I will make them show. So that's the front plane of the yoke mail. And now for the pin, let me show you this one too. Okay, so mate. We see that it was a front plane and the long pin, a front plane too. And now you see the long pin is center. They can move both together. But the long pin is center with the femoral yoke. Let me insert the spider. Can I try to rotate this one alone, but it will change its position with the mate. Oh, there's one thing that I can do right now that will be very helpful. No, I will do it after because I know what I want to do. But so spider, here we go. For the spider, I will center the spider with the femoral yoke too. And I will also make the concentric. So let's put the concentric first. Here we go. And now let's put the plane between the long pin. So the long pin, the front plane, this one, with the front plane of the spider. Let's look at with this one. Enter. So now my spider is always centered in the middle and I don't have to find the distance that I need to apply inside. It's just center. That's so much easier. Let's insert my short pin. One on one side. And let's insert my second one right away and my short pin on this one. Oops. So for the mates, I have this one concentric with this one. Here we go. And I have this one, not the same concentric, but I like to select the same size. Okay. And now I need to put some tangent. So this one will be tangent with the outside there. And this one, where is my little one? There. With this face. Can I, let me remove this one. Let me move this part first. And it's an advice in general. It's better to try to position the part, the closer, because by default, when you do your mates, SolidWorks will select the closest surface. You see now it's on the right side. Okay, and now we need to put the spider, this concentric of this spider. So this one with the pins. Here we go. We love that. One last thing. Okay, so it will look like this one. The spider should be centered with the femoral yoke. That's the femoral, this one. So let me close my mate and show you the plane. So I want to use that's the femoral. The front plane. So I select the yoke mail front plane. Now I need to select for the spider. Don't select the same plane, the front plane, like we did for the yoke femoral. We need the one that is perpendicular to the right plane. Here we go. That's look great. So you see, it stays center, it can rotate. Oh, that thing that we need. This surface should stay, I would say coincidence, but if we put coincidence, it's too much constraint. So let's just put parallel between this one and the surface below. Oops, here we go, this one. Oh, it can, oh no, parallel. You see, it switched for parallel. So it just means that it cannot do coincidence. And let's look at this. Yay, and if you rotate, yes, that's work well. And we can see that when we rotate, the female, oops, the female stay center on the surface of the bracket. So I miss now a few parts on the top, the crank. So we miss the crank arm, the knob, and the shaft. So let me insert all of them at the same time. Let's put them how they will be, the knob, and this one, let's put it there. Here we go. So the first one that we need to insert is this one, and let me put first the surface mate between this one. Oops, not this one. This one and this one. Oh, other directions. Boom. Okay. We need to put this one and the one inside parallel. Don't put coincidence, that's too much. Okay, we need to put just parallel. We need to grab this surface there. Here we go. And parallel. Otherwise, we cannot put the coincidence. Okay, and now we need to put this cylinder and this cylinder concentric. Here we go. That's exactly what we want. Now, this arm should go on top of this one. With this surface, here we go. And this one should be parallel. Okay, so make sure that you select parallel. We don't want coincidence because we will not be able to put the concentric after. It's not exact. Oops. Just remember that you don't put more, you don't block more degree of freedom that you need. Never. We need to put the concentric between the knob. Oops, this one. And we have one more. So let's move this one between that surface and look at the knob below and this surface of contact. Here we go. So let's check that. Can we rotate? Yes, awesome. That's exactly what you want. You can check when you go, or let's save that. It's a long time I didn't save. Oops. You can do a few check clearance verifications between, I don't remember which one I asked you, but maybe the spider and this one. And calculate. Oh, it's in millimeter. Look at that. I need to change for my IPS, my units. It's not because your parts are in IPS that your assembly is in IPS. Make sure that you have the right units for your assembly too. So you see 0.39, that's I think what I was waiting for, but as soon as you were able to find a clearance, that was okay. And you can see where in the clearance. See, that's this little gap between the spider and the yoke female. Interference detections. Oops. So you click. That will make the calculation on the assembly, because that's the assembly that is selected by default. And you can see there the little interference between the two parts. And we can see that it's between the yoke male and the yoke female. If you want to just try so clear selections between two parts. So for example, you want to see if there's an interference between this pin and the spider. and the yoke mail. Let's say in the yoke mail, and you see calculate, and they say no interference. So you can select any two parts. So do we have an interference between this one and this one, for example? Calculate, no interference. Okay. So you can either select all your assembly and do a calculation, and it will tell you, or let's see if I can rotate at the same time, but not. Or and when you block, one last thing, when you block your the rotations for the mass center, so I click this one and this one. Why I do have to? This one, and I make them parallel and enter. So now I cannot move anymore. That's the way you submit your assembly. You can suppress anytime any, so you click right and suppress any mate. So now I can move again, and you can come back and you see it's in gray, and unsuppress, and it will go back. Okay. And unsuppress. Okay, so I will and always check the way it's moving. So I think that was the easiest way to do your mate, to have something correct and moving as request. I will show you the exploded view in another video because it takes a time. So I wish you a great day. Bye bye.